Now in this video we are going to see how to assign the IP addresses on the Cisco routers and what are the commands we need to use to do that. Now the basic thing before I actually go and assign the IP addresses on the devices, we are going to implement some basic things. Like the first step, we are going to design the topology. Now designing the topology is nothing but providing a connectivity as per our requirement. So here my requirement here is I want to connect router 1 to router 2 via back-to-back cable, which we'll be using here, and then we are using a router to switch, we are using a straight cable, and then switch to PCs we are using a straight cable again. Same thing, straight cable here and then straight cable here. So that is something what we are going to do first, and then after that the next step is we are going to assign the IP addresses. So while we are designing the topology, I'm going to give some more information on the different kinds of ports and port numbering also, and then finally we'll use these commands to assign the IP address. So I'm getting back to these commands. Before that, let's go ahead and design the topology first. So here you can see as per my topology requirement, you can see on the left side I have my topology. I need at least some couple of computers in the LAN, so I'm going to drag and drop some computers here, assuming that I got some computers in the LAN, PC0, PC1, PC2, PC3, and some computers on the right side as well. So which is going to assume as two different LANs, and here it will be 192.168.1 network, and the other side it will be 192.168.2 network. So we'll do that from the basics. And then I need one centralized switch minimum to provide a centralized connection here. So I'm going to take some 2 switches, and then I need some routers here. So click on the router here. On the left side you can see you have different platform routers. We can use any platform. I'm using some let's take router 1. I'm going to take 2621XM series router. It can be any router, you can take any platform, only the port numbers might vary based on the platforms. So now the next step is we need to provide the connectivity between them. Now to provide the connectivity, you click on this button here on the bottom. You'll see the different kinds of cable connections here. So I'm going to take a straight cable, copper straight through, which is going to connect from fast Ethernet port on the PC, and then on any port on the particular switch. Straight cable connecting from fast Ethernet to any port on the switch, and a straight cable connecting from fast Ethernet to any port on the switch. Same way I'm going to do the connection on the right side also. So when you're doing some switching concepts, you need to remember which port you are connecting on the switches. But as of now here, we don't need to worry. Any port it can be. Ensure that it is a fast Ethernet port. Now similar way, we need to use the same straight cable which is going to connect from fast Ethernet to F0 by 0. I'm connecting F0 by 0. Either you can use F0 by 0 or F0 by 1, any one port. So I'm using F0 by 0 here. So ensure that whatever the port you are connecting on the router, you just write down or remember that. So in my scenario, on this side, on the router 1, I'm using F0 by 0 here, and here also I'm using F0 by 0. So why? Because on that port only we need to assign the IP address as per the rules. So I'm going to assign 192.168.2.100 on that particular port. Similar way 192.168.1.100 on this particular port. So that's the reason. Ensure that you remember those connections. And router to router, I need to have some back-to-back cable. If you come back here, you have one back-to-back serial cable, and just click on the router. So right now I don't see any serial ports. Why? Because whenever you get a router, if you click on the router, if you see the size, you can see by default when you get a router, this is the back side of the router, power button, and there is a power cable, and then by default this router is having some fixed ports. You can see. Now similar kind of thing you'll find on the back side of the port. If you remember, we have seen in the basic slides, in the basic classes, these are fixed ports. Now this router is having fixed a port of F0 by 0 and F0 by 1, and apart from that there is no other ports, but you have only slots available here. You can see these are the slots. Now on these slots we need to add the card. So if you remember, it's a modular router, and all the modular routers, if you want to add any card, we can add. Right now at present I need a serial card. Now on the left side here you can see the different kinds of cards. You can see NM1E. NM1E is nothing but one Ethernet port it supports. like that. You have different kinds of cards here. If you click on it, you can see the physical view how it looks. And then NM1E fast Ethernet 2 WAN slots, I think it will fix here, exactly here it fits. And then these are different types of cards. You can see, just if you click on this particular different types of card, you'll find some information over there which is going to support 2 WAN slots and 2 Ethernet ports. Here you can see, and then 1 serial or ISDN port. You have 1 serial port, you can see 60 pin 1, like that. So right now the one which we use most commonly for serial connections here is WIC2T card. This is the card, WIC2T card, or WAN interface card with 2 serial ports. So that's what exactly it says. WIC2T means 2 serial ports. So even you have 1T where you have 1 serial port. Even you have 8 also, like if I just take 8-1, this is the 8 port 1, this one. Even you can have 8 serial ports. Depending upon the requirement, we can go with any one of the card. But ensure that you power off the button, power off here, and then take this card and then drag and drop on the particular slot. Now if you're doing on the real devices, it's going to be very similar. When you're doing on the real devices, we need to ensure that we power off the particular router before you add the card. And you just need to unscrew this one. Whatever the ports you will find here, you have to unscrew it, remove the cover. And once you remove the cover, you just need to place the card inside here, and then you have to fix the screws. Okay, so you cannot do hard swapping here because it can damage your slot, or it can damage your card here. So ensure that you power off the particular routers when you are adding or removing the cards, or removing anything. So just ensure that you don't do hard swapping like that. Okay, so similar way, the same thing. Right now I'm adding the card here and then power on the router. At this point of time, I just need only 2 serial ports. That is sufficient. I got 2 serial ports. I think that will be sufficient for me to add. If you want more, you can add more and more here. So just power off and then WIC2T card and then power on. So the same way, if you are doing on the real devices, just remove the screw and then put the card inside, and then make sure that you are inserting in a proper way, horizontal a little bit inside the particular rack, and then fix the screws. Once you fix the screws, it's going to fix exactly on the motherboard. And once you are done with that, power on the router and go to show version command. Ensure that when you use show version, it is going to show you these slots or the cards in the show version. So I can go and verify like that. I can go to router 1. This is my router 1. So let me go to the command line and then setup mode, and then I can use show version command to see. It should show you that 4 serial ports which I added just now. So if you're able to see that, it confirms that that you have added the cards and it is successful. Or you can also use show IP interface brief to see the exact numbering, this 0 by 0 is 0 by 1. Now understanding this numbering is also important. Okay, so understanding this numbering is also important. Let's try to understand this numbering kind of thing here. Now this numbering, it all depends upon the slot you are selecting on that particular routers. Right now this router is having 2 slots. This is slot 0 and then this particular is slot 1. Okay, so if you're adding the card on that particular slot, right now here you can see this port numbering here. This port number you will find when you just elaborate, you will see S0 written here and S1 written here. So this numbering will be S0 by 0. The first number represents the slot and the second number represents the port number, and this first number represents the slot. And then similar way, if I just go with the other port, it will be S0 by 1. Similar way, this is S0 by 2 and then this is S0 by 3. So it shows as S0 by 2. Why? Because we already have a card here and S0 by 1 is given already. And in case if I don't add the card here, if I add only here, in that case also you'll see S0 by 1 and S0 by 2 anyway, S0 by 0 and S0 by 1, that differs. If I add the card in this slot, again the numbering will be S1 by 0 and S1 by 1, because this is a slot 1 and the port number is 0 and the port number is 1, and the third card will get a port number of 2 and 3, like that it will go on. So depending upon the slot you are selecting to add the cards, the numbering goes. And if you realize there is some, if you have any confusion, you can always use show IP interface brief command. Show IP interface brief command will show you the exact numbering on that particular router. So you got some different special routers. If I'm going to connect some of my 28 or 1800 or 1900 series routers, or 28 2900 series routers, these are ISR routers we call them as. If you are going to take this router, on this router, if I zoom in, you have some different slots. Here you can see the numbering is, this is my slot 0, and then the numbering, I think this is, if you just see the numbering, you'll find slot numbering, I think this is 0 1 2 3, like this. Now you have a main slot here. Now this is what we call as main slot, and then inside that main slot again you have a sub slot, and then you have a port number. So let's say I'm inserting the card here and the port number is 0 and 1. The numbering for this particular port will be S0. The first 0 represents the main slot here, and the next number represents 2, which is the sub slot number, this one 2, and then the port number will be 0 here. So you will find 2 slashes. So this is something you will commonly find in, if you are using some 800 series, not 1800 series or 2800 series routers or 3800 series routers, which are called as ISR G1 routers. And then the next release, now these are the next version released after 2600 routers. And then now Cisco announced some ISR G2 routers, which are the latest release from the Cisco, which are 1900, 2900 series and 3900 series. We call them as ISR routers. So ISR stands for integrated service routers. Now the good thing about these routers are they are multi support. They do routing, and also if you want, you can add some switch modules, like you can also connect a switch, and also they can be used in a voice network, where you can add some voice modules, voice cards, where you can connect some IP phones, and also you can implement some security implementations like VPNs kind of things, VPN, DMVPN, those kind of implementations also supported on this particular models. So that's the reason we call them as ISR routers, integrated service routers. Okay, so just to differentiate, and if you're using fixed routers, anyway we don't have any fixed router here 2500 like that, you'll see the port numbering will be either S0 or S1, S2 like this, E0, E1, no slashes. So no slashes means there is no slots in simple, we can say. So right now I'm not taking the router 3. Okay, so now I'm going to add the same thing on the router 2 also. Power off the device, WIC2T card on the slot 0, and then power on the device. So let's do the same thing. Now the router to router, we need to connect a back-to-back cable, if you remember, serial back-to-back cable. And also remember which port we are connecting. I'm going to connect S0 by 0 going to any port, either S0 by 0 or S0 by 1. Let me make it S0 by 0 on both the sides. So whenever you are doing the physical connections, you must make sure that you write down the port numbers, because on that particular port numbers only we need to assign the IP addresses. So on both the sides I'm using S0 by 0 just to make it simple, and here also I'm using F0 by 0, F0 by 0 just to make it easier for me to identify. The best practice, start with 0 port number. If it is already connected, go with 1. Already connected, go with 2, like that. That's something I generally prefer to follow when I do the connectivity kind of things. Now the next step is, now we are done with the first step which I discussed, designing the topology. The first step is designing the topology, where we did the physical connections of our devices. Now exactly the same way we need to do on the real devices also, where you need to connect a straight cable from the router to switch, and the back-to-back cable we connect from router to router. Now once we do the connectivity, simply connecting the devices is not sufficient. The next step, we need to assign some IP addressing. So IP addressing as per the rules. Remember the rules? In the previous session we discussed that. So in my scenario here, I got everything as per the rules. On the PCs, I'm going to assign the IP addresses as 192.168.1.1, 1.2, 1.3, 1.4, and here I'm using 192.168.2.1, 2.2, and then 192.168.1.100 here, and 192.168.2.100 here. This is 2.100. Okay, and then here I'm using 10.001, 10.002 with /8 subnet mask. Okay, so it's up to you. We can use 192.168.3 as well, just to differentiate between the LAN and the WAN. I'm using in the LAN I'm using C class network, on the WAN I'm using A class network, just to make it differentiate. But as long as they are in different networks, same networks, whatever the class, whatever the IP address, you can assign. Now to assign the IP address, we need to go to the command line. Let's say this is the IP address. I need to go to the interface. Type means we need to tell whether it is a fast Ethernet or serial interface. Right now it is my fast Ethernet interface. And then number. What is the number we are using? S0/0. And once you use this command, you go to the interface mode. And inside the interface mode, we need to say IP space address. And you have to type whatever the IP address we decided. I think we decided 192.168.1.100, and then give some space and write down the subnet mask. So I'm using 255.255.255.0 subnet mask, and then I have to give no shutdown command. Now this command is mandatory, we need to give, because by default all the interfaces of the router will be in shutdown state. Shutdown means they are in down state by default. We need to make sure that we make them up mandatory. Okay, so let's go ahead and try to configure the same thing on the router 1 first. So I'm going to router 1 here. Is it router 1? Let me check. Okay, let's go to router 1 command line. On the router 1, I'm going to assign the IP address. So the first thing, I'm going to change the name of the router just to identify and differentiate between router 1 and router 2. And in the next step, I need to say interface. Which interface we want. I'll go with F0/0 first here, fast Ethernet 0/0, and you can say IP address. What is the IP address? 192.168.1.100, and the subnet mask is 255.255.255.0. Then no shutdown command to make the interface up. Now same way we need to do the same thing on S0/0 also. S0/0 interface. Go to that interface. Inside that interface, we need to tell the IP address. I decided to use 10.001 as per the rules, and then 255.0.0.0 subnet mask, and then no shutdown command. Now there is one more command we need to add. There is something called clock rate. Now this clock rate command is only applicable in the lab scenarios. Now why only in the lab scenarios? Because in the real production networks, we have a router connects to the modem. If you just get back to our slide here, so in the real production network, if you remember, you have a router which is going to connect to the real modem here. Now this is your CSU/DSU modem, which is going to generate some clocking, which is going to help your data to send over long distances. Now this modem is going to generate the clocking in your real production networks. But when you come back in your lab scenarios, we are going to use this back-to-back cable. And this back-to-back cable will convert one side to DTE, the other side to DCE, and we must add clocking manually if you want to send the data over the WAN. So clocking has to be generated manually by the administrator if you're using back-to-back cable. So in my labs, we are going to use back-to-back cable. Even if I'm doing on the real devices in my lab scenario, I'm going to use back-to-back cable for WAN representation. So this is something only applicable in the lab scenarios, but not in the production networks. Okay, so you can keep this command only in the lab scenarios. So here also we need to give clock rate mandatory. So once you are done with this on the router 1, let's go to router 2 and do the same thing. Go to router 2, go to the command line, and on the router 2, you go to hostname R2, interface fast Ethernet 0/0, and then IP address is 192.168.2.1, 2.1 or 2.100, 2.100. If you see on the router 2, 2.100, and then we need to say no shutdown command, and interface S0/0, it is say IP address 10.002, and then the subnet mask is this, and then clock rate command doesn't apply on the other side because this is DT is DT interface, and to check which is DT, DTE, DT, DCE, then you can use a command called show controllers S0 by 0. Now you'll see this interface is DT interface, but not compulsory. It's not really mandatory for you to do these things, but just for verification we can do that. And from the router 2, if I try to ping to the router 1 interface 10.001, you can see the ping is successful. I can ping from router 2 WAN interface to the router 2 WAN interface, which confirms that this connectivity is okay. And similar way, I should be able to ping between my PCs here as well. So let's do that in the LAN also. So in the LAN, what I'm going to do is, to test this, I'm going to assign the IP address on the PCs. If you remember, I have shown how to assign the IP addresses. Just go to desktop and IP address configuration 1.1, and then we need to tell what is the gateway address. Now the gateway address is nothing but the address of the router. So if this 1.1 user, if it want to communicate with any other device or other network, it first should go to the gateway. Now to send your packet to the other network, it should go to the router, and your PC should know who is the router and what is the address of the router. And this is what your default gateway. So whenever I say default gateway, it's simple. It is the address of the router. The router address is referred as the default gateway. So we must tell the gateway. If I don't tell the gateway, let's say, in that case, the PC don't know who is the router, and your packet will not go outside the LAN. If you want the packet to send outside the LAN, you must tell the gateway. So for all the users sitting here in this LAN, the gateway is 192.168.1.100. So let's go to the next PC, 192.168.1.2. If I give 1.1, it will not accept because it's already existing, just like conflict message. 192.168, the subnet mask is 255, and then the gateway is 192.168.1.100. For the next PCs here also, the IP address configuration is 192.168.1.3, and the gateway address is 192.168.1.100. And for all the users sitting in this LAN, the gateway address is 192.168.2.100. So on this PC, go to desktop, 192.168.2.1, 192.168.2.1, and the gateway address is 192.168.2.100. So similar way, the same thing on the second PC also, we need to say IP configuration 192.168.2.2, the gateway address is 2.100, and on the third PC also we need to do the same thing, 192.168.2.3, and the gateway address is 192.168.2.100. So now if you want to do some basic testing in the LAN, I can go to any one of this computer. Right now I'm on my first computer, which is my IP config 192.168.1.1, and I'm trying to ping to another computer that is on the other one, 192.168.1.2. You can see I'm able to get the reply, and I'm trying to ping to 1.3. I'm getting a reply, and I'm able to ping to 1.100 also. So I'm able to get the reply. But you cannot ping to 2.1 still, because there is something more we need to do. Routing is required anyway, but the same network can ping with each other, and the same network can ping with each other. But if you want to ping from one network to another network, we need to do something called routing. That's something we'll be getting into that more in detail in our later on sessions. So once you are able to ping between the same networks, it confirms that your connectivity within the LAN or in the WAN is working fine.